In this video, what I'd like to talk about is partitioning. Partitioning is a really great tool to get children's understanding of number and place value. Without the understanding of place value, they're going to find it really tricky to understand other concepts, especially when it comes to things like addition and subtraction. So what I'm going to show you today will link to addition and subtraction units as well as multiplication and division as we go on. I think this is a great place to start, mainly because this is where we would start with learning from September. I'm going to start by showing you lower numbers that would work with year 1-2 age, and then I'll show you what a 3-4 application would look like. Generally it's the same, and with this I would say make it as practical as you can do if their understanding of number is quite low. Make it as physical, so get them doing things as well as using pictures and written, like drawn methods to help them as well. So place value is the understanding of knowing where numbers, the value of numbers within any given number. In year 1, for instance, and year 2, we mainly start with ones and tens. Now, you would have learnt this as tens and units, but it has been changed to ones. So, in a number such as 36, this number will have a certain amount of tens and a certain amount of ones. Now, when you're doing basic place value, it's all about partitioning and separating to find the value of each digit in that number. So it's really important that they understand that this will always be the tens number in a 2-digit number, and that this section here will always be the ones digit in a ones digit number. One way that we show this is by using what's called a part-whole model, and that's just to show that this number here is the whole, but we separate it into 2 parts for a 2-digit number. So we start with either the tens or the ones. Now, before we even get into using number representation, so by writing the number, we use practical and concrete methods to show this. One way that we show this is by using something called the Deans or the base 10 equipment. So in this, for instance, you'll have a tens block, so a tens Dean, which looks like this. Now, these are magnetic versions, but we would get the children to use the physical versions instead at school. And then you've also got the ones Dean that looks like this, just a little square. Now, obviously these aren't always available, and at home at the moment they're not going to be available to you either. So what you can do is by drawing them on pieces of paper, so showing a block of 10 and then showing a ones block. What's really important to remember is that these go hand in hand. So the ones cube, well, square, is the same size as the ones on the 10. And what they can do is count, so 1, 2, oh, this is really hard, 3, 4, 5, 6, 7, 8, 9, and 10. So what you can show is that this is the tens and this is the ones, and the reason I know it's 10 is because I can fit 10 ones in the same. And they can represent it in the same way. So if their number understanding is still quite low, what you can get them to do is get 10 of the ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as you can see, the 10 ones is the same size as the 10 Dean. I would say that's about year 1, beginning of year 1 application. However, it depends where your child is with their learning journey. It might be that this is where they are at the moment, and that's absolutely fine. And what we need to make sure is that this understanding is solid so that you can then move on to the other parts as well. Now, like I said, at home, you're probably not going to have these. And as the children go later on into their journey of learning and understanding, we wouldn't always make these available to them, because what we would give them the option to do is to draw them. So again, if you're drawing, all you actually need to do is just show that representation. So this is the physical, what we call concrete resource, but then we also do the pictorial application as well, is where you draw a picture. So this picture would represent tens and this picture would represent ones. Now back to the partitioning, like I said, it's all about tens and ones in here, and I'm going to partition it into two separate sections. Now to begin with, we teach this as one side for tens and one side for ones. Later on, this will change as they start to partition numbers in different ways. To help you, I'm going to do that in a separate video, so I'm going to keep this very much separating into tens and ones to help with application. So, if I'm looking at the number 36, what I would ask a child to do is make that number 36 in Deans. So, for instance, I'm going to show you by using my concrete resources, so I can show you this easily. So 36, I know that to get 36, I need to count 10, 20, and then I can count 30. Just like that. And then in 36, 10, 20, 30, 31, 32, 33, 34, 35, 36. From this, what I would ask them to do is to separate it into tens on one side and then ones on the other side. So this, I can then pick these up, which is really nice. What's good about the concrete resources is that you can move them around and manipulate them to help you with your learning. So I would put my tens in the tens section, in the tens circle, and then I can put my ones in the ones circle. Now that I've separated it into tens and ones, now I can have a really good understanding as to how many tens there are in that number and how many ones there are in that number, because I'm counting them as separate parts. So this here would be 10, 20, 30. So this number is made up of 30. And then this part is made up of 1, 2, 3, 4, 5, 6. So then I can put these to the side and I can complete my whole model by writing the numbers then. So I've gone 36, we'll have 30 and 6. Now if I was to try this with a different number, so I rub out this number in my whole. Now remember, the top part is always, well, not the top part essentially because they will move around, but the main bigger circle is always the whole. The two separate numbers are really important to keep an eye of, because this means that these two numbers go together to make the whole. That's really keen to remember. So now if I was to make this into bigger numbers, so I would say that would be something I would expect them to do towards the end of year one. Now these numbers, we're looking at bigger numbers, over 50 towards 100. So I might be looking at numbers such as 80. Oh, we did 6 last time. Let's go for 83. Now, like I said, one way they could do it is by drawing pictures. So instead of using my concrete resources, I'm going to move them out of the way because I'm not going to use them this time. What I could do is draw the tens and ones instead. So I'm going to take my pen and then I'm going to draw the tens. I'm going to count it just like I did before because it's really important. I don't know if you can see that. It's really important to remember, there we go, that these are representations of the place value, okay? So these have to be tens if I'm doing 80. So I count them like I did before. So 10, 20, 30, 40, 50, 60, 70, 80. So I've got 80 in this section, and then to show the 3, I would then do the 3. So 10, 20, 1, 2, 3. Remembering not to count them as tens because they're not tens, they are 1. So then I can count them up and I can see how many there are all together. So the number 83 is made up of 8 tens and 3 ones. You can use this method when you come into bigger numbers as well. So say I was a child working maybe at a year 3 level, I would be looking at 3-digit numbers. 3 digits get a little bit trickier because there's a lot more to remember. So this is where some children can get confused as to the place value because they're so used to only looking at 2. So now we're not just looking at 2 anymore. The numbers that we're now looking at have got 3 digits in them. So So these numbers will have hundreds, and they will have tens, and they will have ones. So it might be a number such as 481. Apparently I like 80. So 481. Now you can do this with a part whole model. It's exactly the same, but this time we need to separate into 3 parts if we were going to show the representation for all 3 parts. And like I said, sometimes you can partition in different ways, so we're not just looking at the place value. So don't take this as gospel, because things can change. So I will then have my 3 sections, and I can count this as my hundreds, this as my tens, and this as my ones. So for this, the hundreds deans look a little bit different. It's actually just 10 of your tens deans. Unfortunately, I have left them at school, so I don't have them to hand. But it would look something like this. If you were going to write the 3 different, you would have hundreds. Now the drawings don't need to be accurate, they're just there to help you. You wouldn't count out 100 of those, so it doesn't matter, because all it's there to do is to remind the child of what the place value is. So that would be 100, and then your 10 would look like this, and then your 1 would be by itself. And then you can use that to help you. So you can physically get the deans and you can put them in there, but then with this you do need to remember that they're an older age, so really their number of value, their understanding of place value with number would be a little bit more advanced. So they shouldn't really need to get those deans every single time. But what might be quite nice is when they're going to add numbers together is to partition and then use their drawings to help them. So in here, because also I don't have lots of room, as long as I'm drawing the markings on them, I will know that these are hundreds. And then these would be my tens, 20, 30, 40, 50, 60, 70, 80, and then my 1. So in here, I have got 4 hundreds. So 100, 200, 300, 400. And then here I've got 10, 20, 30, 40, 50, 60, 70, 80. And then here I have got 1. So altogether, I have made the number 481. Now, one way that you can use this partition to help is to then add, if you're going to add numbers, you would then separate the 2 numbers that you are adding together. So it works to help with that. So that's one way, by using a part whole model and by drawing and using the concrete resources. There's so many other resources that you could use as well. So it's good to bear in mind that you don't want your children to be reliant on just one method, because one method isn't always going to work. So after this, what I would then teach them to do is, instead of partitioning their number into a part whole model, what I would expect them to do is to then just draw the deans like I said before. So if I was going to have the 2 numbers of 37 add 28, what I would then expect them to do is partition those numbers. So this is 30, so I draw my 10, 20, 30, and then 1, 2, 3, 4, 5, 6, 7. And then my 28 I would partition into 20 and 8. So 10, 20, 1, 2, 3, 4, 5, 6, 7, 8. Now what I can do, because I've drawn my 2 parts of my number, I can then add them together. I always suggest counting your tens first. So like I said, you'd have your 37 and then your 28, and then you can add them together. So I would count my tens first, and then I would add my ones on top. So I'd have 10, 20, 30, 40, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65. And then I can write my answer as 65. It's quite common for children to get confused as to what they're counting. So they might count these as tens, and then they might carry on counting these as tens. At that point, it's really important to stop them and then remind them to start counting again, so that it doesn't confuse them. So yeah, that's one way that you can use that partitioning method. Another way that we like to show partitioning is through something called a bar model. Now bar models are really good for children to get used to using when they're trying to put numbers together, because this will help them when they're doing multiplication, division and fractions. It's a really good way to show how numbers are made up. So it might be, if I can find my rubber, that if you were only adding two numbers together, then you could use your bar model like this. And like the part-whole model, the top part is usually the whole number. So you will usually have one part that is just one block, and then you would separate your bottom number to show the bottom part to show your two numbers that you're adding together. So you could do this with 3-digit numbers as well. It's not just to do 1-digit numbers. So it could be 242 and then 167. Obviously this wouldn't help them with their drawing, so they would also need to do the drawing as well, but it just shows that this is one part of the sum and this is the other part of the sum, and then this is where it would go together. So that's the bar model for that. I think that's everything with partitioning. As the numbers get bigger, so will the deans, the base 10 that they will use. So it might be that they start learning thousands as well, and then it would just go into a different part. So at that point it then becomes a cube. I'm not great at drawing cubes, so please ignore. But the whole point is that they would know that that is 1,000 cube, and then this again is 100, and then this would be your 10, and then this would be your 1. So there's always ways to show pictorially, and that's where we always start, so that understanding is really secure before we then go on to the part where we're looking at mental addition, because without that understanding they're not going to be able to do those large numbers. Let me know if there's anything I've missed that you're not sure on, and I can always add it on as well. Thanks for watching.